Let's see first example how to calculate IDFT of a given sequence using DIT-FFT algorithm. So given example is find IDFT of a sequence x of k 0 minus 2j 0 plus 2j using DIT-FFT algorithm, that is DIT decimation in time. First write down given sequence x of k equal to 0 minus 2j 0 2j. First step, take complex conjugate of a given sequence, that is equal to x conjugate of k equal to 0 2j 0 minus 2j. What is complex conjugate? We have to just change sign of imaginary term. So plus j will become minus j and minus j will become plus j. For this example, number of samples capital N equal to 4. This can be represented as a power of 2. So capital N equal to 2 raised to m, that is equal to 2 raised to 2. That means this example is having 2 stages. Next, for n equal to 4, bit reversal is given as first column 0 1 2 3, second column it's a binary representation, third column reversal of binary representation, and fourth column bit reversed input indices, that is 0 2 1 and 3, where first two indices represent even indexed values and last two indices represent odd indexed values. For n equal to 4, butterflies in each stage equal to n by 2, that is equal to 2. Separation in inputs and outputs, that is given as 2 raised to small m minus 1, where small m represents stage index. So for stage 1, small m equal to 1, that is equal to 2 raised to m minus 1, that is equal to 1 sample. And for stage 2, small m equal to 2, that is equal to separation in inputs and output is equal to 2 samples. The number of complex multiplications equal to n by 2 log n to the base 2, that is equal to 4, and number of complex additions equal to n log n to the base 2, that is equal to 8. Next step, twiddle factor exponents are a function of a stage index m, which is given as k equal to capital N into t divided by 2 raised to m, where t equal to 0 1 up to 2 raised to small m minus 1 minus 1. For stage 1, m equal to 1. So for m equal to 1 value, we will get value of t equal to 0, and for a single t equal to 0, we will get single value of k, that is equal to 0. That means for stage 1, in case of a DIT algorithm, we need only single twiddle factor, that is omega for 0. For stage 2, small m equal to 2. So for value of m equal to 2, we will get value of t equal to 0 and 1, means we will get 2 values of small t. For 2 values of small t, we will get 2 values of k, that is k0 and k1. That means in case of DIT algorithm, for stage 2, we require 2 twiddle factors, omega 40 and omega 41. By using definition of twiddle factor, we can calculate value of omega 40 equal to 1 and omega 41 equal to minus j. Number of sections of butterflies in each stage, it is given as 2 raised to capital M minus small m, where capital M represent number of stages and small m represent stage index. So for stage 1, capital M equal to 2, small m equal to 1. Therefore number of sections equal to 2 raised to m minus m, that is equal to 2. And for stage 2, capital M equal to 2 and small m equal to 2, which gives number of sections equal to 2 raised to m minus m, that is equal to 1. Next, exponential repeat factor, that is number of times your twiddle factor is going to be used. So for stage 1, exponent repeat factor is given as 2 raised to m minus m, that is equal to 2. And for stage 2, exponential repeat factor is given as 2 raised to m minus m, that is equal to 2 raised to 2 minus 2, that is 2 raised to 0 equal to 1. This is what flow graph for n equal to 4 DIT algorithm. As we are calculating here IDFT, input will be complex conjugate of a given sequence, and as it is a DIT, input will be bit reversed or shuffled one. So first input x conjugate 0, second capital X conjugate 2, x conjugate 1 and x conjugate 3. Next, there will be 2 stages as per our calculation. In each stage there will be 2 butterflies. In first stage there will be two sections of butterflies, and in second stage there will be only single section of butterfly. Total factor used for first stage is omega 40, and as ERF is 2, we have to use omega 40 2 times. And for stage 2, total factors required are 2, that is omega 40 and omega 41. As ERF value is 1, we are using this total factor only once in stage 2. Finally, calculating values for stage 1, S1 of 0 equal to 0, S1 of 1 equal to 0, S1 of 2 equal to 0, and S1 of 3 equal to, it is 2j, minus of minus, it is plus 2j, that is equal to 4j. Next for stage 2, S2 of 0 equal to 0, S2 of 1 equal to 4, S2 of 2 equal to 0, and S2 of 3 equal to minus 4. Last, as per our discussion for IDFT using DIT or DIF algorithm, last output will be in the form of capital N into x conjugate n. So x conjugate n will get by dividing your output of stage 2 by 4. So x conjugate n equal to 1 by n into x conjugate n, that is equal to 1 by 4 in bracket 0 4 0 minus 4, dividing by 4 will get x conjugate n equal to 0 1 0 minus 1. But finally we need sequence x of n. So to calculate x of n, what we have to do, we have to take complex conjugate of x conjugate n. So what is complex conjugate? If there is any imaginary term, we have to just change its sign. But for this example, in x conjugate n there is no complex term or imaginary term. Therefore IDFT of a sequence is x of n equal to 0 1 0 minus 1. This is what the example of calculation of IDFT using DIT FFT algorithm.